Welcome back to another episode of the podcast. We have a question today to answer. This is a good one, folks. First of all, they say, thank you for discussing this. Great job. This is in response to a video I did on gabapentin and voltage-gated calcium channels. So thank you very much for the kind words. Can you talk about voltage-gated calcium channel antibodies and what this does? Interesting. So I did some digging. I got some notes here. So I think, yes, I can answer the question. Now, hopefully it's to your satisfaction. So please let me know if that's the case. But thanks again for the question. Let's get into it. So voltage-gated calcium channels, what are they? Well, in short, they facilitate the release of neurotransmitters. So I'm sure we're all familiar with the following neurotransmitter, and that is dopamine. I mean, we're watching this on social media, so we're all on social media looking for the likes and the comments. At least that's me. I post and pray like, oh, please let somebody like this. Oh well, I don't get that much likes. I appreciate all the likes and the comments that I get, but I'm still here, so I got a positive attitude about it. But we're all looking for the dopamine hit. Dopamine is a neurotransmitter that release of dopamine to go from one neuron to another, that communication, for example, in the central nervous system, is facilitated by voltage-gated calcium channels. If you want more information about their function and their structure, where I go into detail about their structure, I'll put it somewhere on here. I've done at least one video at a minimum talking about them before, probably more if I remember right. I've talked about them so much, and all the episodes kind of go together after a while, but I'll put it up there, so watch that. Hey, let me know. I'd appreciate you watching it, so thanks very much. So antibodies. Well, antibodies are our immune system, are part of our immune system. So if we get the flu, for example, all right, eventually our bodies will create antibodies that can then bind onto, in this case, like the flu virus, and one that can prevent it from infecting cells, so making the infection or the sickness worse. It prevents it, but it could also tag, quote unquote, tag the virus in order for our white blood cells to come and destroy it. So it actually helps with defeating the pathogen, in this case, the flu. So if you put those together, then for some reason, our bodies are producing antibodies that then tag or attach to voltage-gated calcium channels. Specifically, if you watch the videos that I put up there, the alpha-1 subunit. It also could attach to the beta subunit, but most of the time it's the alpha-1 subunit from my research. So what does this do then? I mean, what's the result of it attaching to these antibodies attaching to the voltage-gated calcium channels? Well, for some people, they don't get anything at all. There's no symptoms at all for it, all right? For other people, it's possible they could get I would say based on the research, two different conditions that could result. One is called LEMS. So it's Lambert-Eaton myasthenic syndrome. Myasthenic, I believe, is Latin for like muscle weakness. So it's literally Lambert-Eaton, which are two of the scientists that discovered the disease, muscle weakness syndrome. So it kind of describes what it does, or at least in part what the disease does. It weakens muscles, and that's what it does. One of the primary symptoms of Lambert-Eaton myasthenic syndrome is proximal muscle weakness. So proximal meaning like connected to the trunk, so our body. So you could get weakness in the shoulder muscles, maybe upper arms. More often than not, it's in like the hips, the buttocks, and the legs. You will get weakness in those muscles. Now, it could also result in distal muscle weakness. So hands and fingers could get weak. Feet, like calves, toes, they can get muscle weakness in there. You could also get weakness like in your jaw and in your neck. So you get this like extreme weakness. Now, the reason for that weakness, it goes back to what we talked about with the antibodies. So if you have these antibodies that are binding to the voltage-gated calcium channels, and we'll just say the alpha-1 subunit in this instance. What happens is it results in the reduction of the number of voltage-gated calcium channels that are on that cell membrane, all right? Because not only, I brought up dopamine, where you can have dopamine like in your central nervous system, like affecting how your brain views like social media posts and how it craves it or whatever. But there's also voltage-gated calcium channels that are necessary for muscle contraction. As I'm flexing my 20-inch bicep here, all right? So it's what's called the neuromuscular junction. So the nerve cell goes down into the muscle, and then that voltage-gated calcium channels open up to facilitate the release of a neurotransmitter, another neurotransmitter called acetylcholine. I've talked about that plenty of times before. I'll link a YouTube live I did like 2 or 3 years ago. I went like 2 hours talking about different forms of choline. Probably need to update it because I'm sure there's information that I got wrong. I get stuff wrong all the time, folks. But like I said, I'll link it up here. But acetylcholine is necessary for muscle contraction. So if we think about it, all right, I just said we're binding the antibodies to the voltage-gated calcium channels. The result is that reduces the number of voltage-gated calcium channels. Well, if those are needed, I'll just call them VGCCs from now on, voltage-gated calcium channels. If we're reducing the number of VGCCs, but VGCCs are necessary to release neurotransmitters, acetylcholine being one that helps to contract muscles. My arms are so big, I'm getting in my way there. Then if we're reducing the number of those VGCCs, it makes it harder for muscle contraction because your muscles need acetylcholine in order to help with the process to contract the muscle fibers. All right. So that can lead to the muscle weakness. You're actually getting a reduction in the amount of acetylcholine that's released there at the neuromuscular junction to contract those muscles. So that's a symptom of LEMS, is muscle weakness. Another symptom of LEMS is autonomic dysfunction. What that means is basically involuntary processes in the body. There's a dysfunction in them, all right? So acetylcholine, we just talked about, necessary for muscle contraction, skeletal muscle contraction, so voluntary movement. Well, acetylcholine is also necessary for involuntary processes. So the autonomic dysfunction could lead to dry eye because acetylcholine is necessary for that. It could lead to constipation because acetylcholine is necessary for the peristalsis, the undulation of the intestines to help move the substances through. There's not as much acetylcholine, not as much peristalsis. Stuff slows down there, folks, and then you get constipated. You can get reduced sweating. I'll put a link up here. I believe I had an episode. I'm remembering now. I'll put a link up here if it exists. I believe I talked about the process of sweating in acetylcholine. So you can get reduction in sweating, which some people might not complain about that. And unfortunately for men, they can have performance issues because acetylcholine is necessary. How do I say this without getting cut off? Acetylcholine is necessary to help us stand at attention, if you get my drift. All right. So not good. You get this autonomic dysfunction, these involuntary processes that occur in our body. They are affected as well negatively via this LEMS condition. Another symptom, third, it's not the only three, but there's just three that I read about that I think are pretty significant, is auriflexia, right? So a reduction or loss of involuntary muscle movement. So we go to the doctor, everybody goes to the doctor, you sit on the bench and they take that thing and they pop your knee and then your leg flips out. That's what they're looking for. They're looking for that involuntary response. You're supposed to do that. If your leg doesn't kick out, then, okay, there could be some neuromuscular or neuron or some sort of condition, neurological condition that they need to look into. So again, now we've gone over like what VGCCs are briefly. the antibodies for these VGCCs, what antibodies are, and that they're affecting the VGCCs, which causes a reduction in VGCCs, which could then affect voluntary muscle contraction and involuntary processes in the body via this condition called LEMS. And now we get into what causes LEMS. I mean, we know that it's antibodies that are affecting the VGCCs, but what causes that then? Well, there are two potential causes of it, at least through my research. All right. One is paraneoplastic. That's one. Another is non-paraneoplastic. Those are fancy terms of saying one is due to cancer and one is not due to cancer. So the most common cancer that can cause LEMS, and there's also another condition that we're going to talk about, but most common condition that causes LEMS, or cancer that causes LEMS, is called SCLC, small cell lung cancer. I believe it's also called oat cell lung cancer because under a microscope, the cancer cells look like oats. Like if you pour, Quaker Quick Oats into a bowl and you're going to heat them up in the microwave to make the oatmeal, the cells look like that. All right. So unfortunately, SCLC, small cell lung cancer, it is a very fast progressing cancer. It develops fast and it spreads pretty quickly. Some common causes are smoking, firsthand smoke and secondhand smoke, so definitely no bueno. Air pollution, and it's a cancer that forms in the bronchi. So you have your trachea, it goes down your windpipe, and then it splits into the bronchi that goes into the lungs. And so it forms there, all right? These oat cells, or these SCLC, the lung cancer, they can actually develop voltage-gated calcium channels. So the body recognizes, we have something that is not self, all right? It's an invader. It sees the cancer as an invader. So then the body then will take a part of in this case, the cancer cell in order to make antibodies for it. Well, and that part that they take from the cell, like the sample, the DNA, is called an antigen. Well, since they're expressing these voltage-gated calcium channels, well, then the body makes antibodies to the voltage-gated calcium channels. But unfortunately, the body in this case can't tell the difference between the VGCCs on the cancer cell and the VGCCs on, my big bicep in the neuromuscular junction. It can't tell the difference. So it goes after all of them, all right? And so that is one reason why LEMS develops. And so they will abbreviate that SCLC LEMS, small cell lung cancer, Lambert-Eaton myasthenic syndrome. The other one is NT-LEMS, non-tumor or non-paraneoplastic LEMS, right? And that why people develop LEMS that is not related to the SCLC, there could be several reasons, but a couple, it could be a bacterial or viral infection that for some reason turns the immune system against the VGCCs. Another one, which is more likely, is what's called the HLA complex, the human leukocyte antigen complex. And that is essentially the DNA that we get from our parents. Thank your mom and dad. I believe it's formed on chromosome number 6. But essentially, it's the part of the DNA that helps the immune system determine the difference between self and then not self. So it would help the body determine, wait a second, this is a liver cell or a kidney cell. We don't want to bother with that. That's us. This is a flu virus, or this is another virus, or this is cancer. We need to go after that. It helps make that determination. And for some reason, there is some genetic malformation or genetic issue there, DNA issue, then that causes the body then to see VGCCs as being dangerous. And so it starts to attack it. All right. Those are the two main reasons. Now, in terms of percentages from the research, roughly about half the people that have LEMS, who've been diagnosed with LEMS, which I'll put the numbers up here, it's not a very prevalent disease. There's not a lot of people in the population that have it. But unfortunately, if you do, it's not good. But about half the people that have LEMS have small cell lung cancer. Now, this may sound bad, but in a way, it could be a benefit that somebody has LEMS. It's definitely not good, but if it's due to small cell lung cancer, it could possibly be a benefit, because if you're getting the symptoms and are diagnosed with LEMS, then the doctors then can see if you have small cell lung cancer, because it's such a fast spreading form of cancer. Due to the LEMS, you may catch the SCLC faster or sooner, and then maybe have a better chance at defeating the cancer. So, not a great way to say you're lucky, and I guess in a sense I don't really mean lucky, but not a great way to say that it could be better, but I mean, I guess it's a better of a bad situation. Now, the second condition that is related to VGCC antibodies is what's called PCD, Paraneoplastic Cerebellar Degeneration, right? So paraneoplastic meaning that it is due to cancer or cancer-related. So it can be due to SCLC, small cell lung cancer can cause PCD, but it can also be caused by other forms of cancer like ovarian or breast cancer can also cause this PCD. So what happens is these VGCC antibodies are tagging or attacking cells called the Purkinje cells. So there are cells, brain cells in that cerebellum, which is kind of like in the back, it's kind of like the base of the brain. Now the cerebellum, some of its main functions are for coordination, balance, motor control, like movement. So as these VGCC antibodies are attacking these Purkinje cells, the numbers of those reduce, and then you can actually get like motor control issues. So some of the symptoms of PCD is limb and gait ataxia. So what that means is you start losing coordination and control of your limbs, so like your arms, legs, gait, so you're not walking. Walking becomes difficult. You can also get something called diplopia, which is double vision. You can also get something called dysarthria, which is like a speech issue. So you could get like slurred speech, for example. And also dysphagia, so difficulty swallowing is another symptom of PCD. From the figures that I read, it said about maybe 40 to 45% of people that have PCD, they find antibodies for VGCCs in their blood. So that's why I'm listing it here as another condition that can be caused by VGCC antibodies. So then we get into treatment, like what do we do? What do you do if you're diagnosed with LEMS or PCD, which by the way, people can have LEMS and PCD. They can have both. I think it's called PCD LEMS is the short form of it, or like it's abbreviation for it. So what do we do? Well, first of all, it needs to be determined whether the LEMS, for example, is caused by cancer, or is it NT LEMS, so non-tumor LEMS or SCLC LEMS, for example. If it's caused by the cancer, and this is true for PCD as well, the cancer needs to be treated first, and that needs to be put into remission, and then worry about trying to reduce as much as possible the symptoms of LEMS and PCD after the cancer has been defeated. So for LEMS, one of the drugs that can be used, I might have to read it here because I always forget the name, is 3,4-diaminopyridine. All right, so that is a voltage-gated potassium channel blocker. So I'll pop it up here. I think it was a couple of videos where I talked about how the action potential works with neurons. Like how does neuron to neuron communication work? I think it's pretty good detail on it. But the whole idea of neuron communication is based on the depolarization of cells. So inside the neuron, it's normally a negatively charged environment, okay? And by depolarization, so it becomes much less negative or potentially into the positive, all right, that's what then facilitates this action potential, all right, these ions, these positively charged ions, these cations, which then ultimately help to open up the voltage-gated calcium channels, all right, to then release neurotransmitters, all right. Well, you don't want that action potential going on forever, so then the cells or these neurons then want to repolarize or even hyperpolarize to get back to like the state of homeostasis to get ready for the next communication. Well, one of the ways it does that is these voltage-gated potassium channels. Potassium is a positively charged ion, and so the neuron will open up these channels to then flush out the potassium ions to then help reduce that potentially positive charge inside the neuron to help get it back to closer to zero and then into the negative space to repolarize it, all right? Well, this I had to look here because I forget again, 3,4-diaminopyridine, it helps to it blocks those potassium channels. So then it's keeping that neuron depolarized longer. So, and like my thinking, I didn't read this, it's just trying to think about it logically, is that you're trying to get those muscles, those neurons to fire more to potentially get those muscles to contract more, all right? Try to squeeze as much out as you can out of the whatever voltage-gated calcium channels are left, VGCCs are left. Another treatment for LEMS is an acetylcholinesterase inhibitor. All right, so acetylcholinesterase is the enzyme that essentially cleaves acetylcholine into its component parts. All right, because just like with repolarizing or hyperpolarizing a neuron, you don't want the neurotransmitter, in this case acetylcholine, to be sitting in the synaptic cleft, constantly agonizing or attaching those receptors for a long period of time. That's bad news. So the body has acetylcholinesterase, which then cleaves those acetylcholine molecules. And so it goes back to its component parts. So then it can be reassembled and used again into acetylcholine, and then it can be used again. Well, an acetylcholinesterase inhibitor, what it sounds like, it inhibits that enzyme. So then whatever acetylcholine is there in the synaptic cleft, from however many VGCCs are left from LEMS in this case, then you could take advantage of keeping that acetylcholine in there longer. Now, this is a little bit of a side. I think I had it in my live. I'll pop the live link up here again. Sarin gas, all right? That is a gas that was formed by the bad guys from World War II, right? I know saying the actual name of it is no bueno on social media, but the bad dudes from World War II, I believe the name sarin is the initials of the scientists who actually created it. Well, sarin gas is a permanent acetylcholinesterase inhibitor. So it permanently inhibits acetylcholinesterase. So what happens in that case is you get this acetylcholine goes into the synaptic cleft, it's always there. And so usually people who are poisoned with sarin gas, they end up asphyxiating. So they end up choking because you can't control the muscles that then control breathing. All right. So again, it's dangerous stuff when you mess around with acetylcholinesterase inhibitor. I believe, is it huperzine A? Huperzine A is a supplemental form of acetylcholinesterase inhibitor. It's real popular in nootropics and in pre-workout supplements, all right? But it's a temporary acetylcholinesterase inhibitor. So that's another medication that can be used, and there's different forms of acetylcholinesterase inhibitors, different medications, but that's another thing that can be used for LEMS. There's also immunosuppressants that can be used, so drugs that help suppress the immune system. Obviously, the antibodies are attacking the VGCC, so then if you try to tone back or pull back the immune system, calm it down, then maybe it doesn't attack the VGCCs as much, not as much damage being caused. Also, IVIG could be used, which is intravenous immunoglobulin, which is a form of antibodies. It's one of the 5, I think, different forms of antibodies there are. That can be used as well, and that could be helpful for patients with LEMS. Now we get into treatment for PCD, as I said before. You want to treat the underlying cancer first, all right? That's the primary. But in terms of symptoms of PCD, from reading the information, usually a lot of the treatments don't really do much for people that are suffering with PCD, unfortunately. I could be wrong. I'm not an expert on this. I just like reading about this stuff. But usually not much can be done for what's already occurred. Now, with the treatment, hopefully you can either reduce or maybe prevent, or hopefully prevent any further damage. But not much can be done once it's already done. So similar, you can give intravenous immunoglobulin. I got it here. I'm reading it because I don't remember it. Intravenous immunoglobulin. So again, one of the 5, if I remember right, 5 antibodies that can help keep it from the damage from getting worse. Another class of drugs that can be given for PCD is corticosteroids. So that helps with inflammation, just keeping inflammation down. Again, the primary treatment with PCD would be to treat the underlying cancer, and then with LEMS, if it's a paraneoplastic with LEMS, due to more than likely SCLC, then you want to treat the cancer first. But those are a few treatment options. So that's it. Again, folks, I am no expert on this. I'm not a medical professional. I just love studying this stuff. Please do not take my word as gospel. This is strictly for educational purposes only. Always discuss with the medical professional, folks. But it never hurts to have some information. You can certainly show your doctor the video, and then maybe they'll tell you that, man, that dude, he don't know what the heck he's talking about. Well, wouldn't be the first time that I heard that. I mean, I hear it all the time. But thanks again for the question. I hope you found this valuable. Please let me know if there's any other questions that you may have. Please like, subscribe, share, comment, all that good stuff. And until next time, drink your milk. Make sure you get that calcium, because VGCC is certainly needed. All right, take care, folks. Bye-bye.